Welcome to qnawire.
This is the diagram of the system, and for part A, we can say that at the North Pole, the factor m omega squared times r, the mass times the angular velocity squared times r, is going to equal 0. And so there's no effect from the rotating reference frame, and so g prime would be simply equaling g minus omega squared r, which we know to be equaling g minus 0. And so this would simply be equal to g, or 9.80 meters per second squared. The direction would be inward, or we can say radially inward. And then for part B, to find the direction relative to the radial line, coordinate the coordinate system along the tangential x and then the radial y. So y, we're going to say is always along the radius, or essentially towards the center of the Earth. And then we can say that at a specific latitude phi, describing again the latitude, the true gravity will point purely in the positive y direction. So we can say that g prime would be the vector g would be equal to the magnitude of g times j hat, and we can then label the effect of the rotating reference frame as g. We can say the g sub rotate. This would, or ROT. This would be the effect of rotating reference frame. So essentially, the effect of this vector here can be found by using it along the axis, and we know that the new r would be equaling the radius of the Earth times cosine of the latitude phi, and so we can then say that g sub rotate would be equaling r omega squared sine of phi I hat, and then minus r omega squared times cosine of phi j hat. Again, we're getting this from the diagram. And this would be equaling the radius of the Earth, omega squared, times cosine of phi sine of phi I hat, minus the radius of the Earth, omega squared, cosine squared of phi j hat. And so we can then say that the true gravity, we can say g prime would be equaling g plus g sub ROT, and this would be equaling the radius of the Earth, omega squared, cosine of phi sine of phi I hat would be the only component in the x direction, and then plus g minus r sub e omega squared cosine squared of phi j hat. And so here we know that for part B, theta, the angle of deflection, here can be found from the components of g prime. So we can say that theta would be equaling arctan of g prime sub x divided by g prime sub y. We can then say theta is equaling arctan of r sub e omega squared cosine phi sine phi divided by g minus the radius of the Earth, omega squared cosine squared of phi, and we can solve. So we can say theta is equaling arctan, it's going to be quite large, This would be the radius of the Earth, 6.38 times 10 to the 6th meters, multiplied by 2 pi radians divided by 1 day, or 86,400 seconds, quantity squared, multiplied by cosine of 45 degrees, sine of 45 degrees. Again, 45 degrees would be the latitude in this case. And then this would be divided by 9.80 meters per second squared minus 6.38 times 10 to the 6th meters multiplied by 2 pi radians divided by 86,400 seconds, quantity squared, and this would be times cosine squared of 45 degrees. Close parentheses. This is after solving everything. This is essentially equaling to 0.988 degrees. This would be the angle of deflection. And so we can find the magnitude of the true, for part B, the magnitude of G prime. This would simply be from Pythagorean's theorem. So this would be G prime sub x squared plus G sub y prime squared. This is equaling. You're going to get these values once you solve for this. So solving this first and then solving this will give you the x and y components. And so this would be 1.687 times 10 to the negative second meters per second squared, quantity squared, plus 9.783 meters per second squared, quantity squared. And so G prime would equal 9.78 meters per second squared. Again, this would be the magnitude, and then it would be 0.988 degrees south from an inward radial line. This would be our full answer for part B. And then for part E, we're trying to evaluate this at the equator. And so at the equator for part C, we can say that G prime would be equaling G minus omega squared R. And again, at the equator, the effect of the rotating reference frame is directly opposite to the true acceleration due to gravity. And so this would be equaling G minus omega squared times the radius of the Earth. And so this would be 9.80 meters per second squared minus, and then this would be 2 pi radians divided by 86,400 seconds, quantity squared, multiplied by the radius of the Earth, 6.38 times 10 to the 6th meters. And so G prime is equaling 9.77 meters per second squared. This would be inward, or we can say, again, radially inward, or inward along a radial line. That is the end of the solution. Thank you for watching.